Right, today in geometry, we are looking at section 12.3, surface area of pyramids and cones. So let's start out with some vocabulary. A pyramid is a polyhedron whose base is any polygon and the lateral faces are triangles meeting at a vertex. The height of the pyramid is the perpendicular distance between the base and the vertex, also known as the altitude. So then I just gave you some examples of pyramids here. So here we look at our base. It's a square pyramid. Okay? The lateral faces are all triangles meeting at the common vertex. The second one is a triangular pyramid because my base is a triangle. The next one is a hexagonal pyramid because my base is a hexagon. A regular pyramid is a regular polygon for a base, and the segment joining the vertex and the center of the base is perpendicular to the base. The lateral faces of a regular pyramid are congruent isosceles triangles. The slant height of a regular pyramid is the height of a lateral face. A non-regular pyramid does not have a slant height. And then I've given you examples of that right here. So we see this first regular pyramid. This is a regular rectangular pyramid. The slant height is the height of that lateral face of the isosceles triangle. The height of the pyramid is straight down the middle. An irregular pyramid, you see, has the altitude, the height straight down the middle, but the lateral faces are not congruent isosceles triangles, so there's no slant height. Okay, so now we're going to look at the formulas for lateral area. So the lateral area of a regular pyramid is 1/2 capital P times L, where P is still the perimeter of the base, and L is now the slant height, which happens to be the hypotenuse. If I also have the height of the actual pyramid. So if I have the height of the actual pyramid, then the slant height will be the hypotenuse for the triangle that I make. If I don't have the height of the actual pyramid, then my slant height is not the hypotenuse out of the triangle that I make. And we'll see some examples of that. The surface area of a regular pyramid is the lateral area plus capital B. And remember, capital B is just the area of the base. Or the surface area is 1/2, okay, perimeter times slant height plus capital B. All right, so now we're going to talk about a cone. So a cone is a circular base and a vertex that is not in the same plane as the base. In a right cone, the slant height is the distance between the vertex and a point on the base edge. So again, here we see that our slant height would be the hypotenuse in this cone if I know my height and my radius. The lateral area of a cone is perimeter times the slant height. The perimeter of the circle is pi r, so the lateral area of a cone is pi rl. The surface area of a cone is 1/2 capital CL plus the base, okay? C is the circumference of the base, which is going to be 2 pi r. So then the surface area would be pi r squared plus pi rl, which is the lateral area plus the area of the base, which is the circle. All right, so now we're going to look at some examples. This is a regular square pyramid, has a height of 15 centimeters and a base edge of 16 centimeters. Find the lateral area. So the 16, that's the bottom here. The height of the pyramid, that's the height in the center, is 15. So remember, our formula for lateral area is equal to 1/2 the perimeter times the slant height. I can go ahead and find my perimeter, right? My perimeter is 16 times 4 because there are 4 sides to a square. So we see that our perimeter is 64 centimeters. Now we need to find our slant height. The slant height is the height of one of these isosceles triangles. So I need to pull that out. This is the height of the pyramid, 15. This is my slant height. The entire base was 16. Remember, when I pull half of it out, I have half, so this is 8. So Pythagorean theorem tells me that 8 squared plus 15 squared is equal to L squared. So here I get 64 plus 225 equals L squared. So 64 plus 225 is 289 equals L squared. So when I take the square root of that, L is equal to 17. So now I can plug this in. The lateral area is equal to 1/2 my perimeter, which we said was 64, times the slant height, which is found to be 17. When I multiply all of that together, I get 544. I found area, so square centimeters. So now example number 2, we're going to find the surface area. So first, to find the surface area, I need the lateral area, right? So I need that perimeter. So I know my perimeter is 24 times 4, which is 96. I need my slant height. Okay, I do not have the slant height. This is the edge of the isosceles triangle. It's the legs of the isosceles triangle. The slant height, remember, is the height of that triangle. So again, I need to find my L. This is what I'm looking for. So this is an example where my L is not the hypotenuse. So see, in this first one, the L was the hypotenuse because I knew the height of the actual pyramid. Number 2, I don't have the height of the actual pyramid, but I have a leg of the isosceles triangle, which is my hypotenuse, 20. Remember, this whole bottom was 24. I took half of it, so 12. So here, L squared plus 12 squared equals 20 squared. L squared plus 144 equals 400. L squared equals 256. So L is equal to 16. So my surface area is 1/2 my perimeter, 96, times my slant height, 16, plus the area of the base. The base is a square, so that is 24 times 24, or 24 squared. So here, if I add all this up, 96 times 16 and a half is 768, plus 24 squared is 576. So I add those two together, and I get a surface area of 1,344 square feet. So now number 3, find the surface area when the side base is 13 feet. And I should have added in here, and the slant height, because we need more information, and the slant height is 20 feet. So I should have that in there as well. Okay, so I know that each of these are 13. So I'll find my perimeter. So my perimeter is 13. So I count up how many sides do I have? 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So 13 times 8. Our perimeter is 104. So our surface area is equal to 1/2 the perimeter, 104, times the slant height, 20, plus the area of the base. Our base is an octagon, so remember the area of that is 1/2 the apothem times the perimeter. So we need to find our apothem here, right? And again, that's this side when we make that triangle. So again, I would do 360 divided by 8 to get that big central angle of 45. But then when I draw that triangle out, I have to cut 45 in half. So this angle is 22.5. I'm looking for my apothem. I know that this started out being 13. I cut that in half, and this is 6.5. So now I have the tangent. So the tangent of 22.5 is equal to my opposite, 6.5, over my apothem. Cross multiply. I end up having to divide by the tangent of 22.5 to find that my apothem, and remember here, this is where we're going to round to 4 decimal places. So I get that my apothem is 15.6924. So now I come back up here, 1/2 my apothem, 15.6924 times my perimeter, which we said was 104. So now I want to multiply all of this out. So 104 times 20 cut in half is 1040. Plus 104 times 156, sorry, 15.6924 cut in half is 816.0048. Add those two together, and we get the surface area is 1,856.0048, so 0.0. 1,856.005 square feet. So still finding the apothem the exact same way that we did in chapter 11 and that we have done in our other lessons here. Okay, so next example, find the lateral area and surface area when the side base is 10 feet and the slant height is 14 feet. So here I know that these are 10 and the slant height is 14. So I know that this height here is 14. So the lateral area is equal to 1/2 the perimeter, 10 times, we have 1, 2, 3, 4, 6 sides, so 10 times 6 or 60, times the slant height 14. So 60 times 14 cut in half is 420 square feet for our lateral area. So our surface area is our lateral area, 420. That's the area of the base. The base is a hexagon, so that's 1/2 the apothem. So again, 360 divided by 6 gets me 60, but I have to cut that in half. So I know that this is a 30, 60, 90 triangle. This was 5 down here. I'm looking for my apothem. I can do SOHCAHTOA or I can use my shortcuts. Okay? So I have the short leg of across from 30 is 5. I'm looking for my long leg. So my long leg is my short leg times the square root of 3. So my apothem is 5 square roots of 3 times the perimeter, which was 60 times 6. So 60 times 5 square roots of 3, and then cut in half. So we have 420 plus 259.8076. So when I add those together, I get that my surface area is 679.8 square feet. Okay, so now we're going to look at some cones. So number 5, find the lateral area and surface area. So the lateral area of a cone is pi times the radius times the slant height. Here they give me the diameter is 10, so my radius is half of that, 5. So pi times 5, they gave me the slant height, 13. So my lateral area, 13 times 5 is 65 pi square feet. And again, I could multiply that through by pi if I wanted to give the answer as a decimal. So then my surface area is my lateral area, 65 pi, plus the area of my base. My base is a circle, so pi times radius squared, 5 squared. So here I have 65 pi plus 25 pi. So my surface area is equal to 90 pi square feet. And again, if you wanted the decimal, I would just multiply 90 times pi. So let's look at another cone, find the lateral area and the surface area. So again, here, I don't have my slant height, so I'm going to have to find my slant height first. It is the hypotenuse because I have the height of the cone. So I'm going to have L squared equals 6 squared plus 5 squared. So L squared equals 36 plus 25. L squared equals 61. So L is the square root of 61. And I'm going to leave it as the square root of 61 in my formula. So the lateral area is equal to pi times my radius, 5, times the square root of 61. So now I want the square root of 61 times 5. That's about 39.1 pi, so this is approximately 39.1 pi square meters for my lateral area. And my surface area is my lateral area, 39.1 pi, plus the area of the base, so pi 5 squared. So 39.1 pi plus 25 pi. So then I get the surface area is approximately 64.1 pi square meters. So now we're going to look at a word problem. It tells me that Dixie Incorporated manufactures paper cups for snow cones. Each cup is in the shape of a right cone. So I'm just going to draw the picture of that because I'm a very visual person. A diameter of 5.5 all the way across. So my radius is going to be 5.5 cut in half. So that radius is 2.7. And a height of 8. So they're giving me the height of 8. How much paper is used to make each cup? They didn't tell me, do they want me to find lateral area or surface area? So let's think about this. If we get a cup for a snow cone, does it have a top to it? Is this going to be paper on the top? Well, if it is, then we can't have any snow cone put down in the cup. So we do not want the area of the base. We want this to be open, right? So that means the lateral area, because there is an open top, right? Which means no base. So we're finding lateral area. To find lateral area, we need the slant height, right? And so I need this L. So this triangle that I have, this is my L, this is 8, this is my radius, 2.75. So L squared equals 8 squared plus 2.75 squared. L squared equals 64 plus 2.75 squared plus 7.5625. Add 64 to that, so I get that L squared is equal to 71.5625. Take the square root of that, and I get the the L is about 8.4595. So then I can say that the lateral area is equal to pi, there's my radius, 2.75, times my slant height, 8.4595. So then my lateral area is 2.75 times 8.4595, and I'm going to go ahead and multiply through by pi so that I know exactly what this is. So my lateral area is approximately 73.1 square centimeters. That's about how much paper we would need to make each cup for our snow cones. All right, so that wraps up section 12.3.